Hello, we are Spaced Out Incorporated, founded by Talon Fisher, Elena Bauer, and myself, Max Martinez. Our objective today is to design a constellation of satellites to orbit and observe the surface of Bennu. We want to maximize scientific value with the fewest amount of satellites necessary, and our solution is a constellation of 4 satellites on polar, near-circular orbits in the same orbital plane that orbit in different directions. Each satellite will orbit at a different altitude and different orbital period. The scientific value of our proposed constellation is estimated to be 373,948. The first step of the design process is determining the orbit of each satellite. We've determined that a polar orbit is the best option for many reasons, the biggest reason being that a polar orbit has the best chance of flying over every point on the asteroid. After modeling orbits with different inclinations and propagating a series of orbits in different orbital planes versus the same plane, the overall values of the constellation were significantly different from each other, and this ultimately led us to have our constellations in the same orbital plane. To ensure they will not collide with each other, each satellite is on a different orbit dictated by its orbital radius. The elements of each orbit at the end of a 1-week period are summarized in the table. Next, Elena will discuss how we determine the number of satellites for our constellation.
The next step of the design process is to determine the number of spacecraft we want. Keeping our goal in mind, needing to maximize the science value JSV, we can simulate how the value changes with the number of satellites. This is possible because JSV is a function of ground resolution, which is a function of the number of spacecraft. As seen on the top right, our JSV maximizes at 4 spacecraft with a value of 373,950 and then decreases with more spacecraft. This is because adding more satellites becomes unnecessary and wasteful, as it causes the field of view to decrease for each satellite, as seen in the equation below on the right. We also want to conserve the number of satellites in orbit, so adding more would not make sense. Next, Talon will talk about our final product.
On the left is an animation of the constellation in the inertial frame. In this frame, the orbits are clearly stable and the spacecraft are in no danger of colliding with each other or the asteroid's surface. The animation on the right shows the constellation in the rotating frame fixed to the center of Bennu. This shows that the constellation has excellent coverage over the entire surface, allowing for maximized science value. Our solution is best because we maximize the science value of the mission. Having more spacecraft only serves to limit the field of view of each spacecraft, so the total science value decreases. Having fewer spacecraft means slightly less coverage of the surface and lower science value. Additionally, as seen on the figure to the right, the constellation is able to view the entire surface of the asteroid in only 1 week. Lastly, since our orbits are circular and coplanar, there is no danger of them colliding. We also account for SRP disturbances by making our orbits orthogonal to the incoming solar radiation, meaning SRP does not push the spacecraft out of their orbit plane.